or 1. I'll remove BGP first of all. Okay, there is no routing protocol. I remove BGP. Now, about OSPF, you should know one thing. OSPF with MPLS, you should know something. Or is that you already have a OSPF area 0 here. Can I have another area 0? Answer is yes, you can have. Secondly, if I have area 10 here and area 11 here and OSPF area 12, will they be able to distribute the routes? For that, answer is yes. But we know OSPF connects through area 0. But we don't have area 0. How is this possible for area 11 to give routes to area 12 and vice versa? Now, what is the role of that middle area 10? Nothing. Area 10 has got nothing to do here. Area 10 and this area 11 has got no connection. Area 10 is of service provider. Area 11 and 12 is of customer. So they don't belong. Usually we say there should be a backbone area and there should be all the regular areas connected like this. Correct. Only then area 11 can give routes to area 12. This is what the general idea that we all have about OSPF. And it is correct. But in here, I have OSPF on 2 different locations. Actually, I should say OSPF here. Yes, R2 and R1 belong to same customer, 2 remote sites. So, is there any area 0 in between? No. Then how? How area 11 routes will come to area 12? Answer is this VPN is of BGP. So there is no need for area 0. In short, we are going to redistribute from OSPF 11 here to BGP. And from BGP, we are going to take and give it to OSPF 12 here. So the VPN itself will act as a super backbone. Super backbone. There is no need for area 0 to be a backbone. Alright, so to understand that, I'll remove ISS from here. I'll send the RIP protocol here. And I'm going to have OSPF on the other side. Area 12. Area 10. This is going to be totally different OSPF. So let's not disturb this one. Let it be area 0. But I'm telling you, we're going to have different OSPF on R3 and R6. You know one thing? You can run any number of OSPF instance in a router. Any number of OSPF instance in a router. So, or if you want me to change this, I can change. The problem is it will take time. I have to go to all this router and change. But one thing you need to be informed that on R3 I'm going to have two different OSPF. So definitely this OSPF and that OSPF is different. This area 0 doesn't matter for us. Okay, so I'm back to R1. Show IP protocol, no protocols. As we discussed, we are going to have OSPF. Router OSPF 1. Actually, no need. You can go straight to interface. OSPF 1 area 10. Interface G IP OSPF 1 area 10. Show IP OSPF interface brief. So OSPF area 10 is running on this two interface. R1 is ready. Now focus, we need to now learn how to get the routes from this customer. Let me give a name for this customer. Customer Tinku. And this is customer Binku. Tinku and Binku. Alright. So now customer Tinku R1 is over. Let us try to bring the routes of customer Tinku R1 into R3. How? In R3, we already run BGP. Let's remove that. Show run section router BGP. If you see, we run BGP under VRF. VRF called a new. No, VRF called 1. This I'm going to remove. Router BGP 10. No. So show IPBGP, show IPBGP summary. Show, this is simple IBGP within the autonomous system. Show BGP, VPN, V4, unicast, all summary. You don't see 13, 13, 13, 13. Right. I don't know who is this 39. This also need to be removed. Anyway, we are going to remove all of this. So let me go to BGP again. Show right section router. Except the VPN thing, I'm going to remove. Okay, then let the internet be there. Let's not disturb 39 and remove this. All right, so we got one which is of internet. I'm not touching internet subject today. I've given you homework. Finish it today one more time, and then we'll check it. So internet, I have offed it today. That's why it is idle. It's okay. This is IBGP for the transport network. VPN network is a virtual network we call a service network. The underlay is the transport network. Now, I was telling you that we'll use BGP to provide, OSPF to form adjacency with the customer. But you know, the customer is not connected to a default routing table. It's connected to a VRF routing table. What is the VRF name? Show IP VRF. The VRF name is 1. 1 is the VRF name given to Tinku R1. Tinku R1 is connected to G3/0. So what I need to do is I need to go under interface G3/0. This is the easiest way, I'm telling you. There's another way. This is the easiest way. Go straight to this interface which is already in the VRF and then say IP OSPF, give different process ID. Wake up. Different process ID. This is different OSPF. Already I have one OSPF which is running within the service provider AS10. This is different process ID. That's why I said this area 0 of service provider has got no connection with the OSPF that runs on Tinku. So IP OSPF2 area 10. Now I'm expecting OSPF neighbor. Look at this. We formed a neighbor via process ID 2. Loading to full. G3/0. I would like to verify by typing show IP protocol. I see that I got OSPF 1 with this router ID. Below, if you see, You got BGP, but where is OSPF 2? OSPF 2 is not for the global routing table, so it won't display here. You have to type for VRF. What's the VRF name? It is new. Yes, I think. Now you see VRF new has got BGP 10. Who is the 73? Oh, here. Not VRF new. We need VRF 1. VRF all. All doesn't exist. Star? No? Okay. VRF new. VRF 1. See, if you see VRF 1, we have BGP 10, which I want to remove this. I don't know why still it is there. We don't need that anymore. This is what we need. See, this is a different OSPF, different router ID. Kindly focus. When I simply type show IP protocol, the global routing table OSPF has got this, and it is OSPF 1. But now the VRF also runs OSPF, but there is different process ID, different router. This is totally different. Different OSPF. This OSPF and that OSPF cannot work together because they are in two different VRFs. Right. What's next? Let us check the routing table of customer 1. Show IP means customer think show IP route VRF 1. You can see now we are learning route via OSPF name. This is the interface via which we have OSPF. Excellent. What is next? We need to now remove OSPF, whatever the protocol on the R6 towards the customer. We were having eBGP, so let me remove eBGP from R6 towards R2. Now we are 10 address family 2 new finish. Likewise, I'll also cancel which we had with router 8. Router 8 is called as new customer. Okay, so router 6 is not having any eBGP with the customer. I would like to configure OSPF area 12, do show IP VRF. Area 12 is connected to new customer VRF on interface G4/1. Okay, first is VRF2. Focus on VRF2. VRF2 is connected to G3/0. If you want to run OSPF 12, I told you the easy way is go to the interface which is already in VRF. What if that option is not available for me? Then you have to do this. Router OSPF 2 VRF 2. Okay, this is the procedure. So this OSPF is for VRF 2. If you want, you can give router ID manually. Otherwise, it will pick one interface from the VRF table. VRF's routing table. I'm going to say router ID is 16.16.16.16. Next. Network is 26. Area 12. Now, if you want to verify, show IP OSPF interface for VRF, interface brief for VRF, no, show IP show VRF to show IPv4 OSPF no IPv4 show IP VRF to oh my god, I want to see the interfaces of OSPF. I think it's not needed. I can say show IP OSPF to interface brief. When I say 2, it already knows I'm in VRF. Okay, so this is the interface that runs for towards the customer. Whereas if I cut this one, it is going to show you the internal part of it. Okay, it's showing common. It's a common output. Some operating system in like iOS XR you have specifically. Here it says these two belong to internal. This one is the external one. OSPF is running, that's the proof. Now on R2. New router BGP, I think I had 200 here. Remove it. To show IP protocol, nothing should be there. Wonderful. Now interface range loop 0. Come on. G3/0. IP OSPF 1 area 12. See here I'm saying OSPF 1. There's nothing wrong. This is process ID, locally significant. Doesn't need to match. Boom. See, the neighbor is established now. You remember I gave 16, 16, 16, 16 as the router ID there? Okay. Now, I'm expecting route on R6. Show IP route VRF2. See, I'm learning from Tinku router 2. Yeah, I'm learning the route from Tinku router 2. On R3, We are learning from Tinku router, this router 1. This will not be shown now because we have removed BGP from the. Okay. Now you are learning from Tinku, and then here also on R6 you are learning from Tinku. This is the right final output. One more time I want to show you on R3 you don't see those things which you are seeing earlier because we have removed BGP. Now why are we not seeing 2222 here, and why we are not seeing 111 or router 6? Only when you get these routes 111 and 2222 on either side, you will be able to ping from here. See, right now there is no route. There is no route to the remote site. R1 also don't have any route to the remote site. So if you don't have route, then you cannot ping, right? Why we are not seeing route? See, in BGP, when we were having BGP instead of OSPF, earlier we were running BGP. That time the route distribution was happening automatically. It was distributed, it was distributing the routes automatically. Now, we need to take these routes from OSPF and give to BGP. Earlier it was only BGP, so it was happening dynamically. Whatever customer was advertising, eBGP gave to the tunnel, and it went to the other side of the tunnel, which is also built with BGP. But now, customer is not with BGP, but tunnel is built of BGP. Tunnel is made up of BGP, but customer is in OSPF. Customer is provided route that you see here on router 3. Is provided the route to the provider. In this VRF table 1, you have learned the route. So it is now our responsibility to take the route, put it into VPN. And on the other side, take from the VPN, put it into OSPF running interface, which is facing the customer. Only then R1 can learn the routes of R2. Only then R1 can learn the routes of R2. Right now we don't have route. R2 also can learn the routes of R1. Only when we do that. Let's do it. This one is not seen in the VPN now. Show IP v4 show IP BGP VPN v4 unicast all summary. Sorry, all. You don't have any routes in the tunnel. As I said, tunnel is made up of BGP. The routes are not coming from BGP, they're coming from OSPF. So what shall I do? Redistribute into BGP. For which I should go to router BGP 10, address family, understand, I need to go under IPv4 VRF 1. Why I'm going inside this? Because this is the VRF which is having that OSPF route. So I'm going to the BGP of that same VRF and saying redistribute OSPF 2. Boom. Don't go under VPN. Don't think we are taking from OSPF and giving to VPN. So we need to go to address family VPN v4. No. VPN is already established. You go to the routing instance and get the OSPF into it. See, now if you go and check the VPN command, you already have coming from customer. This is directly connected. But you see, both are question mark. What is next? Next is I need to go to R6 and do the same thing. R6 right now will have the routes from R3, means R1, show IP, BGP, show IP, show BGP, VPN v4, all. Right now you are seeing the one from the remote. It's coming from the remote. It's redistributed. But you don't see 22222 here. On R6 I don't see 22222. Why? Because we didn't do the OSPF redistribution into VPN. So I say router BGP 10 again. Address family IPv4 VRF 2. Redistribute OSPF 2. That's all. Now if you go and check the VPN, you will see even this 22222. Going back to router 3, earlier we were not seeing 2222 inside the VPN tunnel. Earlier we were not seeing 2222, now you will see that. Also the 26, that is also running OSPF. Fine, but the problem is, it is only seen in VPN. When I go to router 1 and check the routing table, I don't see 2222. But it is there in VPN. I showed you just now. Router 3 VPN, you see, it has got. It even has it in the routing table. Show IP route VRF 1. See, I also have, but as what? BGP. Why? Because we took OSPF route on R6 that is coming from the customer R2. We redistributed into BGP because BGP is what we are having to get routes from the remote side. BGP is what running VPN. That's why I said BGP acts as a super backbone for us. Now, from this backbone, we have to translate, redistribute into OSPF. Then only then R1 will be learning the route. So I have to go here. Array router OSPF 2 VRF 1. What am I doing? Don't we have VRF 1? Let me see. Do show run section router OSPF. Oh, I should not do in router 1. I should do it in router 3. That is why I was surprised. All right. Okay. I'm on R3. Router OSPF 1. Oh no. Router OSPF process ID 2. VRF 1. Redistribute BGP 10. You don't need to say anything like address family and all inside OSPF because you are already given very clear instruction that this is for VRF 1 related. So I say, even if I say redistribute BGP 10 may have multiple customers route, but they won't be advertised because you got route target. The route target knows what to give and what should not be given. But this is OSPF, you need to use the keyword subnet. Boom. Now if you go and check on R1, you will find the routes to reach 2222. Dish. And you see, as I said earlier, the VPN is seen as a super backbone. See, it is not showing external. Do you see E2? Please, those who know OSPF. Usually when we have a redistributed route, how we will learn? E2. Yes or no? But you see here, you are learning as if you are learning from inter area, other area, which means it shows like as if you are learning via area 0. How do you learn from other area? Via area 0. That's the reason why I was using the word super backbone. The VPN is acting as a super backbone. All right. Now R2 don't have a route. R2 don't have a route. What shall I do? Again, same procedure. Go to R6. Router BGP, router OSPF 2, VRF 2, redistribute BGP 10 subnets. Now R2 also should have route. If you try pinging from here now, 1.1.1.1, source 2.2.2, the ping goes. Right, so we got OSPF on the customer side, and we saw how to ping. Let's trace route. You will see MPLS, you will see path taken very nicely. You see? There is a VPN label 21. There is a transportable 20 and 17. At last it goes to router 1. Hmm. Hmm. What? Hmm. Okay. Yeah. Yes. Uh, okay. No. For me, no confusion. For see, listen. Tunnel is between which router to which router? R3 to R6. Because we are tracing route from R2, you can say 6 to 3, right? R6 to R3. M&A, we are picking from R2 and D. So tunnel is between R6 and R3. Kada? Right. Now, when R6 sent to R5, R6 only puts this label 20/21. And R5 receives it, that's why you are seeing this. Listen. Label impose, mean label adding, will be done on R6. will that happens in R2? Tell me. Adding label happens only on R6, correct? Then how we will see labels when in the first line? R2 shows that I am going to R6. 26, 26, 26, 26. So don't expect label there. Now, R6, when it is sending to R5, it puts two label, which means it has got a transport label to move the packet from 6 to 5, and it has got VPN label to move the packet from 6 to 3. That is why if you see the 21 on 13, 13, 13, 3, it continues till the tunnel endpoint. So line number 2 to 4 is a tunnel. Tunnel labels. Tunnel service label is 21. To move the packet from 6 to 5 is 20. From 5 to 4 is 17. And 4 will do PHP, so there is no label. And 21 is what received on R3, and R3 understands, aha, this is a tunnel traffic, 21, and I need to pop because the tunnel ends here. I need to pop, and it delivers to router 1. If you didn't get the answer to your question, repeat the question. What? Yes. Okay. Oh, listen. No, wait, listen. It's a very good question. Please understand what our Murli has put it in our table. It is fleshy meat and good soft drinks. What he says is, what we all should ask is the same question. His question is a very nice question. He says, when R5 was sending the traffic to R4, I can see R4's address 10.45.0.4. But when R4 is sending to R3, why I am not seeing 10.34.0.3? That is his question. Correct, Murli? That's the other way of asking that same question. Why the next stop is R3's customer facing interface? Understand understand this very well. VRF membership is only for G3/0. That VRF is the mouth of VPN. VRF is the mouth of VPN. So traffic enters or leaves via that mouth. But tunnel is between BGP neighbors, R3's loopback and R6 loopback. It is not R3's 10.34.03. Understand? It is not 10.34 or 10.56. We were forming loopback to loopback. So that is how VPN should be, so that when the customer traffic comes via VPN, it can go directly to the customer's interface, not to the default routing tables F0/0 interface. From VPN, the traffic should go to the customer interface. Why should it deliver to the PE routers F00? That's meaningless. Then again it has to check for routing table, which routing table I should give. Then there is no point of having VRF. VRF is the mouth of VPN. VPN should know via which exit interface I should send it out. Only then it can be a mouth of it. Only then you can say VRF is a part of VPN. So answer to your question is, Murli, VRF is a part of VPN. When a traffic comes via the VPN, the virtual connection, it knows the exit interface very well and it delivers via that interface. That interface only belongs to this traffic belongs to that interface, because that is the network 1111 learnt via G3/0, which came through VPN. When R4 received the traffic, the VPN traffic, it did not receive from F00, it received from G3/0 of router 3, because that is the VPN opening. Anything that enters into G3/0 exits on G3/0 on the other side, not on F00 of the PE router. So VPN knows the exit interface, so it is sending via that exit interface. VPN knows very clearly which interface can take you to that 1111 network. Murli. That is also happening, That is also happening. R3's identification is what 13.13.13.3 for that customer. For that customer, see, customer is using VPN, not the physical F00 or the LAN interface, the wires. Correct. For customer, R3 is 13.13.13.3. Correct. No way. If you don't have MPLS, then you don't have labels. I'm tracing from customer only. Customer only shows all this label, but though we don't have MPLS enabled on the customer. This is coming through ICMP. See, trace route is also ping only. Trace route is also pinging. Hop by hop it is pinging, hop by hop it is getting response. When the ICMP response comes, it brings all this information. Mm. Why not? Yes, yes. MPLS path, if you have purchased, you will see it. Yeah. In the real world, no, let me answer one more thing for your previous question. I don't know about your ISP. See, when you have an MPLS connection, you will see this labels, but there is something called label suppression. It is not actually label suppression; it's TTL suppression. Right now, you are seeing very well that I have 4 routers in between my source to the destination. How do you know? From the trace route. And you can very well say that router 6, router 5, router 4, and router 3 are the service provider routers. And now it is looking like a security threat for ISP. Some ISPs, they don't want to reveal their inside network IP address. See, all their inside network IP address I can show you here, right? 10.56, whose IP address? Service providers. They don't want to reveal this. So they will do TTL suppression. When they do it, you will not see these labels. Even you will not see these many hops. You will see only 2 hops. Let's do that. No. MPLS. MPLS IP TTL, propagate TTL. No to this. No MPLS IP. By default, it is going to propagate TTL, meaning every hop it will decrement the TTL. I'm saying no to it. No MPLS IP propagate TTL. This is what most ISP put inside their network, thinking that this is going to provide security for them, so that their internal network IP address will be revealed to the external people. In that case, you will not see those labels from the customer side. You will not even see how many hops exactly they have. All right, now let us trace route from router 2. With router 2, we no need to do this command. Anyhow, I did nothing wrong. In router 2, we don't have MPLS. You see, I just saw one label. Even this will not be shown, which means I have not done it on R3. I have done it on R3. Okay, this cannot be avoided, but you see, you don't see many hops. All the internal, like the private networks are not revealed now. The service providers' private networks, internal networks are not revealed. You see only your interface, your ISP address, your local, your remote ISP address, your remote local address. So this is what the TTL propagation suppression will do it for you. You will not get a clear picture of how many hops. So it shows only 3 hops, but in reality, it is 5 hops. Yep. What's the next question? We have different process ID, no? We have different OSPF number, right? You are confusing 2 questions. Don't ask me like this. You said how area 0. Anyway, I'm putting your question more clear. He has got 2 part of question. One is area 0 of the provider, and where is the area 0 for the customer? Answer is you have 2 different OSPF. So this area 0 of the customer has got nothing to do with customer's OSPF. So leave this OSPF away, separate. Provider has got reachability through OSPF, whether it is area 0 or area 200, that doesn't matter. Boom. Second question is, for customer area 10, area 12, where is the area 0? That is how your question should have been. We have different process ID given to the customer. I gave 2 on router 3. On router 6 also I gave 2. Doesn't matter, need to match. You can also have 22, that doesn't matter. So this area 10 and area 12, no need area 0 as a backbone because VPN acts as a super backbone. Boom. We redistribute, right, from OSPF to BGP and BGP to OSPF. So VPN acts as a super backbone. Not necessary at all. That area 0 or anything that in the middle will not contribute to your OSPF in the customer side. Right?